Let us learn about principles of object-oriented programming. These are the set of principles of object-oriented programming, that is abstraction, encapsulation, inheritance, and polymorphism. As I was comparing software development or software engineering with other engineering disciplines, we want the software development should also be done just like other engineering, right? So the object orientation supports a programmer to develop any application just like how other engineers develop their products. Like an electronic engineer is making some device or automobile engineer is making some vehicle. So software engineer also want to follow their approach, that same approach. So that approach gives these four principles. Let us see how. See, first of all, when we come to software development, that is programming, what are the main elements of programming? There are two elements of programming. What is that? First is data. And second one is operations on that data, that is functions. The functions perform operations on the data. There may be many functions and there may be a huge collection of data. So when you develop a software is for performing operations on the data only. So programs are based on the data. So data is primary, then the operations on the data are the set of functions on them. So our program contains these. Like if you take a car, like if you take an example of automobile or a car which will have metal or the wires or cables and plastic or fiber, these are the things that are used for making a vehicle. If you talk about electronic, then electronic circuitry, ICs or boards are used for making an electronic device. Now same way, what is used for making a software, we need data and the functions on the data. Now let us learn about these principles. First of all, abstraction. So if you look at a car example, then all the mechanism of the car will be hidden inside some cabin or bonnet, and what is visible outside is the steering and the gear shaft and the pedals for acceleration and all. So these are visible to the user. Everything is hidden inside. How the car is working, user need not know. The driver of a car need not know how it is working. Now same way, if I take the example of a television, complete circuitry is inside one box, and what is visible outside, the buttons, touch buttons or on the remote control buttons for operating it, everything is inside. So what is visible outside? Functions. And he need not know how that television is working inside. So that is abstract. When you don't know the internal details, that is nothing but abstraction. So same way in software also we want to achieve abstraction. We don't want to show internal detail. So these mechanism and the functions, we don't want to see the implementation of the function, how they are working, but just we want the names of the function. So how it is done in object-oriented programming using C++, we write these things inside one class. I'll just write the name of the class as my. So class will contain data and the function. So what is visible here? Only functions. Now here, user, remember one thing, who is a user of a class? Programmer only, not the user of a software. We are talking about a programmer only. Suppose I wrote a class, then the other programmer or myself only. I should bother about just calling the function. I should not bother about how those functions are working. Suppose I wrote the function today, tomorrow I need not look into that detail of how the function is working. I wrote it and finished. Just I should enjoy using it in my programs. That's it. Whether I wrote it or somebody else wrote it. So we don't want to know the internal details, just the function name should be sufficient. That is the meaning of abstraction, and we can group the set of functions together with the help of class. So that's what encapsulation. So this class gives two things, that is abstraction also and encapsulation also. Abstraction in what sense? Just we get the function name, we don't know the working of a function, only we know it when we are writing it. When we are using, we don't know how they are working. Like suppose printf function you have used in C language, thousands of times you may have used, but ever wondered how it is working, how it is displaying on the screen? No, that is abstract for you. So without knowing how the printf function is working, you have used it many times, so that is abstraction for you. Does it mean that you cannot write a function like printf by yourself? Yes, if you study, you can write a function like printf by yourself. So same way, when some programmer has written a class or a piece of code for some purpose, then just you should enjoy using it in a program. You should, that is, include the library, and you should use the objects of a class and call the functions. That's it. You need not worry how they are working. Once you show that these are perfect, just use them. That's what. So class help us achieving abstraction. Then next is encapsulation. So what is encapsulation? So that's already I told you that a television box is a packed box, everything is inside. So what is hiding inside? Data. What is visible outside? Functions. So we have combined the data. Data means what? The cables and the ICs and everything, whatever is there in the television is data. And what the buttons are visible, that is function. Or same way you go to a bank as an object, if you see, then all your account details and your cash and everything inside, that is hidden inside. All your records are hidden inside. Just you call function, deposit, withdraw. You can't say that I am having 100 crore in my account in this bank, I will directly enter into the locker rooms and I will take the cash by myself. No, you cannot do that. You have to follow a function. Same way, you cannot say that I am an electronic engineer, I know how television works, I'll open the box and connect the cables and use it. You cannot do that. You should use function to make it safe from mishandling, not security. Most of the people say security. Is not security. See, I wrote my class, I am using it, so then from whom I am securing it? So it is just avoiding it from mishandling, like how you declare constant variables. So we don't want to modify the value for us only. So same way, it's not security, it's for avoiding mishandling. We hide the data and make the functions visible, and we put all the things together at one place. Encapsulation, data and the functions together. So that's it. A class helps data and the functions together. That is encapsulation. And along with this, in classes we make data as a private. So that's what I was telling you. This is not for security. We want to avoid mishandling of the data. So we make it as private and we make functions as public. So you can see that in a television, everything is hidden inside and the functions are coming out, the buttons are coming out. In a car, everything is hidden inside, only the dashboard is coming out. So functions are visible, you can use those functions. So we hide the data and show the functions, and we also achieve data hiding along with encapsulation. So data hiding comes as a part of encapsulation. Then let us say I have written a class for something called car. Actually, it's a example from automobile. We don't make a class for car, but for understanding the concept, we make the class for car. Right? We may be making classes for a student, we may be making a class for an employer, a customer, or a product, or a passenger, or a flight, or a journey, or a trip, or a driver. We may be making a classes or objects like this, depending on the system for which you are developing a software. But for understanding purpose, we use cars and these television as an example for making understand the concept of object orientation. So let me stick to car only. I wrote a class for car. Now let us talk about inheritance and polymorphism, as these two were interrelated. So similarly, inheritance and polymorphism are interrelated. With the help of car example, I'll explain you. See, suppose you have written a class for car. Somebody has designed a car in automobile. Yes, here we have written a class for car. Then from that car we have BMW. So BMW is a car. So what is BMW? What all you find in the car that is available here. So this is inheriting from car. So somebody, maybe some a century back, somebody has designed a car with 4 wheels and the seats and the driver seat, everything, and with all the operation, that is gearbox and steering and all these things. Somebody has designed this one. So that design is followed by all the cars in the world. So BMW is a car, means it is inheriting everything from that car, that definition. Then same way, Toyota is also a car. And Suzuki is also a car. So all these are cars. They are inheriting all the features of this car, plus they have more extra features. It's not just limited here. In automobile engineering, we find that BMW, they will have their own design, and from that only they will launch one car, and then they will launch a new version of that car and a new version. So it's nothing but inheritance. Like if you take a Toyota, they will launch one car. then from that only they will launch a new model. So by making some changes in this one or some advancement, they will launch a new car. They will not redesign a car from the beginning again. They will design a new car from an existing car only. That is inheritance. Alright, so we want that inheritance to be followed in programming also. Suppose I have written one class, some class, then tomorrow I want another class in which I want all these features plus extra features. So I should be able to inherit, borrow all these features. So we'll understand more while doing some programming. Then last one, polymorphism. What is this? Now just on one point I can explain you this one. See, if you have to learn driving, what do you learn? BMW or Toyota? Suzuki you will learn. If you learn Suzuki, then you will think, oh, Toyota, I don't know how to drive it, I should learn again. No, you learn car. If you learn this, you can drive this also, this also, this also. When you drive this, you will say I'm driving car. When you drive this, you will say driving a car. But the way it runs is different, the way it drives is different. That's it, polymorphism. That's polymorphism. So with the help of inheritance, we achieve polymorphism. Right? The people who are using things need not relearn them. Just they've learned something in the upper part of a hierarchy, the upper class in the hierarchy, then they can manage all this. Same way, if you know how to use a browser, do you need to learn how to use Chrome and how to use Internet Explorer, Mozilla Firefox or Safari? No. Once you know how to use one of the browser, then you can access internet using any browser. That's what, because things are common there. When you are using Opera, you will not say I am using Opera, you will say I am browsing internet. When you use Chrome, you will not say I am using Chrome, you will say I am browsing internet. So that's what you will say, I am driving a car. That's it, it's polymorphism. The name is same, the term I am driving a car, but BMW, I am driving a car, but Toyota, I am driving a car, Suzuki. The word that is used is same, but the work is different. That is what polymorphism is. So I'll show you these things more in detail with the help of code. So in the coming videos, we will see what are classes and objects, what are the differences, how to write a class, how to create objects. So we'll learn syntactically.